Today's discussion will be on the law of electric charges, electrostatic force, which you will find on page 1 of your notes, Roman numeral 2. Electric charge is a physical property of matter that causes it to experience a force when close to other electrically charged matter. There are two types of electric charges, positive and negative charge. Question asked here, do you know who coined the terms positive and negative charge? When you look at the picture here, there's a clue. Now, many people consider Benjamin Franklin to be the father of electricity, but that's kind of an elementary school myth that's incorrectly taught. Electricity was known for some 200 years before Franklin did his experiments with electricity. It was actually discovered in doing experiments with magnets some 200 years before Franklin did it. But they knew about the phenomena of electricity, but there wasn't a lot that they knew about it. And what Franklin proposed was that lightning and electricity were the same thing. And so Franklin proposed some experiments with lightning and electricity. There's a famous key experiment with a kite. There's question as to whether or not Franklin actually did that or he just proposed it. His own writings in the Gazette kind of sound like he proposed the experiment. Although Joseph Priestley, some 15 years later, wrote a book and attributed Franklin to actually doing the experiment, actually gave the date and year of 1752 of when he did it. So there's some doubt as to whether or not that happened. Nonetheless, Franklin, in doing his experiments, he identified that electricity had two different charges or forms, and he coined them plus and minus, or positive and negative charges. Now, keep in mind the atom. There are three basic subatomic particles. So I'm going to go back to that slide just now. There's three subatomic particles, the proton, the neutron, and the electron. Protons are positive, neutrons are neutral, and electrons are negative. Franklin didn't know about the neutral charges, but he identified the positive and the negative charges. A positive charge is from a material that has more positive charges than it has negative charges, meaning that it has more protons than electrons. So if it has more protons than electrons, it will be more positive and thus be positively charged. Alternatively, an object that is negatively charged will have more electrons than it does protons. And because there's more negative charge, the overall charge of the object will then be negative. Electric forces. There's one very common way we can see forces between charged objects. And if you look at the picture of the boy below, you might experience it. You might when you take clothes out of the dryer. What is that? And specifically, if you just take a moment to look at that, you can kind of see it here, but you see it in the shadow. You can see that his hair is kind of puffed out there, and it's almost like it's sticking straight out. So what do you think causes that? Well, this is the electric forces unit, and that's going to be from positive and negative charges. In this case, the plastic slide that the boy was on, had some excess negative charge that negatively charged the boy, and the hair is so light, the mass of the hair is so light that those charges repel against each other, causing the hair to stick up the way it does. So it's from those negative charges from static electricity. Now, the law of electrostatic force says that like charges will repel and opposite charges will attract. So you can have two different conditions for like charges. Two positive charges will repel from each other, as shown in the first image. Two negative charges will repel from each other, as shown in the second. And then a positive, negative, or opposite charges, they will attract, which you see the arrows pointing towards each other. The interaction between charged objects is a non-contact force that acts over some distance of separation. We call this an electrostatic force. And you'll see two underlined words here. Opposite charges are attracted to each other, and like charges repel each other. Going back to the notes, A and B, opposite charges are attracted to each other, and like charges repel each other. Two factors that play into electrostatic forces are the charge of the object. In other words, are they positive? Are they negative? How positive? How negative? Keep in mind, we said that a positive object has more positive protons than negative electrons. Well, if it has a greater amount of positive, then its charge is even more. So the amount of charge and the charge of the objects is the first factor. And the second would be the distance between the two objects, where the further apart they are, the less of the force they exert on each other. The closer they come together, the more of the force that they exert on each other. Now, go back a few moments earlier, I said that they discovered electricity when doing experiments with magnets. If you take two magnets and you hold them far apart, the magnetic force that's between them isn't very strong. But you bring them closer together, and all of a sudden, that force is much more observable. The same thing is true with electrostatic forces. So notice the +1 and the +1 inside the two yellow circles. This is referring to the fact that it's positive, but that the amount of charge, okay? And in the second situation, you'll see that one of those is +2. The only way to make it +2 is that it's going to have a proportional amount of more protons, more positive protons than what it has than what the +1 does. And because of that, we see these little vector rays. We talked about that in the forces and motions chapter, where the vector diagram is going to show both the direction and the magnitude. In this case, it's the strength of that force, and that's the direction that it's pointing. And then the length of the line is referring to the strength of it. Now, neither Mr. Derriman nor myself made up these particular slides. If I would have made sure that this line was equal to this line. It should be. To me, visibly looking at it, this one's a little shorter, but they should be the same because that law of motion, that equal and opposite reaction is still in play here. But what we see on this particular thing is because we increase the charge on this one, the electrostatic force or strength of that force increases, which is why these arrow lines or vector lines are longer. So as this slide here once again is saying that we observe the force of repulsion doubles when one of the charges double. So what do you think happens to the force between charges when we move them farther apart? Let's reveal the answer. As the charges move farther apart, the force between them is decreased. Again, just like magnets that we can observe, the further apart they are, the less the force interacts between them. So putting it all together, the electric force between two charges is directly proportional to the amount of charge. So if there's more charge, there'll be more force. Less charge, less force between the two. And it also decreases in strength as the charges move farther apart, meaning that as you bring them closer together, it increases in strength, and as you move them apart, it decreases in strength.